Hello, ladies and gentlemen. I hope you're enjoying your lunch. I saw Max and a few colleagues next door, so I'm hoping they'll walk through in a minute when they hear my voice starting. So what we wanted to do was kind of finish off things with a very practical look at things that are happening in relation to the energy transition, transformation of our energy systems. And as I introduced myself in the back of the room, I'm a resident of Orkney. I've been up there for 30 years, and during those 30 years, I've been involved in the renewable energy sector. So starting very early days, and a lot of that has been associated with what was called marine energy, and then the Americans came in and called it ocean energy, and now a term we use is blue energy to try and encapsulate wave, tide, wind, floating solar, and thermal energy. And I'm going to speak a bit about those 5 sectors and how they can interact with each other. And what I want to do is reflect on how local can affect national, and actually I would make the proposition global. So it was really interesting in some of the discussions today where we were listening to people who have considerable portfolios of authority, wondering where they were going to get the solutions from and who were they going to get them from. And I'm a great advocate of bottom-up decision-making because I think we get much better solutions that way. So reflecting some of Chris's impassioned pleas about what is the SME community going to do, well, we're going to create the future because nobody else is going to do it for us. It's pretty clear. So yeah, let's get into it. I've got a slide pack that is quite visual, hopefully. I hope you enjoy seeing some of the things that are happening and going on. And there's different parts where I'm going to stop along the way and offer the opportunity to get questions or feedback and discuss things. And so if there's something that you feel is really engaging or you want to get more information, please put your hand up and we can stop and run it in quite an informal way. So just to kind of think about why we're here, in a way it's obvious because of this energy transition, but it still surprises me how few people actually understand the variety of energy forms that we use, because too often we focus on electricity and how we use electricity, and we don't focus on all the other things. And it was great to listen to Sarah, I think, talk about food, and she had it as an analogy, but actually food is a very important part of our energy mix. You know, we use food to give us energy to be able to walk and preambulate and do all of the things that we might want to do. So that's actually part of our energy system. And so the question that we wanted to pose is how and where can blue energy make a contribution to our energy systems? And as usual, my colleagues and friends that were on the panel before set that up really well, outlining some of those opportunities. And the criticality of that is obvious this week, and it's fantastic actually that Greta and the young people of Glasgow are marching around today to impress on people the importance of that. And I'll put my hand up and say I'm an absolute fan of Greta. I think she's fantastic. I think everything she says is wonderful. And I'm just amazed that somebody of that age has so much wisdom inside her. So what we need to do is deal with this challenge of not just replacing the fuels, the fossil fuels that have caused the problem, but also thinking about the social justice, the economic development that's going to happen with that, and the redistribution of wealth. And that's going to be a theme that I probably come back to a few times, because in a community like Orkney, the distribution of wealth is something that we speak about within our community quite a lot. And we see some of the challenges that arise from non-distributed wealth in terms of decision making and the decisions that get made. So a lot of these things are enshrined within the Sustainable Development Goals. And what we like to try and do is reflect how energy can affect and the influence that it can have on all of those Sustainable Development Goals. And in our regulatory systems that we're all working under, traditionally those have concentrated basically on the ecological issues, the bugs and bunnies, and tried to manage that. And they haven't looked at the implications on people and communities. But the SDGs start to redress that, but we've still got a long way to go, because there's very little decision making that actually thinks about the impact on communities, on SMEs, on the full spectrum of the supply chain when decisions are being made. But again, blue energy might make a bit more sense in terms of some of the opportunities we're building than some of the other energy sources, and they can play a different role. And again, I think the previous session showed some of the diversity of roles that technology can play within our society. So as I mentioned, we're going to look at 5 different technologies. And from our point of view, all of these technologies are probably going to play a role in the future. They might be at a different time and a different place, and we'll come back to that as a theme. And they might be at a different price. And one of the things that we constantly try and remind people is that if you look at the whole energy market around the world, there are places today where all of the technologies that we've seen showcased can make an economic contribution as a form of energy. There are very high value markets out there if you get to the right customer and you make the right proposition. So it's not necessarily a question of creating markets, it's sometimes finding the right market for the solution that you've got to provide. So what I wanted to do next is just take a little bit of a deeper dive into global energy markets and look at how we think they might be structured, look at some of the opportunities that might arise from that. And one way that we like to think about it is as a set of grid squares across the world. And if you look at the surface of the globe, there's around 500 million 1 kilometer squares. And the proposition is that each of those 1 kilometer squares has an energy market proposition associated with it. Now, some of them are that there's no market there because it's in the middle of the ocean. There's a natural energy market. But each of the inhabited squares on the ocean, on the Earth and on the ocean have a particular characteristic in terms of energy. And none of those squares are represented in the next square. There's always a subtle difference. And those subtle differences are the things that we end up wrestling with as householders and businesses in our daily lives. Because, you know, if you live in the estate there, you have a different reality to people that live in the apartments over there. It might be economic, it might be positional, but that we need to think about because those people equally deserve an energy solution that's appropriate for their needs. So sometimes when we look at gigawatts or even terawatts of energy, I think we get up to a level of the system that hides the reality of energy for us as citizens and us as businesses on the Earth. So what we need to think about is the variety of energy markets that exist and the things that characterize those markets. And if we begin to understand them, then we can start to identify appropriate technologies to meet those market needs. And just to exemplify that, here's 4 examples of residential markets in warmer climes, if you like, than Glasgow. But it shows that difference. If you think about the energy needs in each of those places, they're very different in terms of the value that's placed upon energy, how that energy is used, and you're not simply going to be able to sell the same products to each of those customers. And to take Sarah's food analogy, which I absolutely loved, you know, we go around the world, we don't see universal plates filled with exactly the same stuff. We all eat different food in different ways at different times. And one thing that I think as a sector, as a blue energy sector, we've probably neglected is the opportunity that's associated with the blue economy. And it's interesting that for the first decade, certainly, of a lot of the marine energy and ocean energy and offshore energy activities, we were looking to export that energy to land. And we didn't really think about how that energy could be used at sea. And there's some pretty big industrial uses, there's big transportation uses, and those might be really good places for us to think for those first steps into our energy markets. Because if you look at those markets, not only are they in the place where the energy is generated, but they often have a higher value and pay more money per kilowatt hour or megawatt hour than the markets that we're trying to compete with in the onshore grid market. So there's maybe a proposition there that perhaps we started looking at the wrong market upon which to develop blue energy, and we were trying to compete too early in the cycle of technology development. So before I go on to look at integrated energy systems, I'll just pause there and just see if anybody's got any observations or questions they'd like to make on that introduction to markets and that side of things. Is there anything that's beginning to kind of move in your mind or that you'd like to question or discuss? Okay. So what I want to do now is to just explore the breadth of the energy system that we're trying to meet. So within the islands in Orkney, this is a question that we've had to address, and I'll show you why in a minute, because we've just established a local energy company which is trying to deliver an integrated energy system. And so what we've done is mapped out these different facets that we see in energy. And what you'll see is it starts from generation and goes right the way through to use. So we don't separate the fact that we're just delivering energy from the fact that we're using energy. We want to interact at all levels in that cycle. And you'll also see that as we go left to right, we're looking at electricity, we're looking at transportation, and we're looking at heat and cooling. And the reason for that is that if we look to create the best efficiency out of the system and to decarbonize what we have to decarbonize, we have to deal with all of those issues. And we think that when you start looking particularly at transport and integrating transport along with electricity, there's some really interesting opportunities there. But also we need to bring in heat and cooling as well. And what you'll also see is that it's not just an internal system. There's ideas about importing energy, storing energy, exporting energy. And that's something else that we need to think about, because there's virtually nowhere in the world where energy is an isolated system that's not connected to other parts or other neighboring places. So in any of these places, we believe there's 5 fundamental requirements for the energy system, and they're set out in those circles. So the first is we need a market. And we'll come back to that, because I think one of the lessons that I've certainly taken out of my career is that when we started off, we came to the proposition with the technology. We said, I've had an idea, I can generate energy, now give me a market to sell that energy to. And maybe that wasn't the smart way of doing it. Maybe what we should have done is thought, there's an energy need, what kind of technology meets that need, and how do we shape that? So we need to think about the market first, but then we need the technology development and funding to meet that market. And it's not just the generation technology, it's also the supporting technology and infrastructure that you need, and sometimes that can become the limiting factor. And again, in Orkney, it's a pretty famous situation now that we've been asking for 20 years to get a transmission connection to the islands, and the system, maybe because people haven't told them clearly enough that it's needed, hasn't been able to deliver it. And it's intensely frustrating. It's also held back the wave and tidal energy sectors, because they were really struggling to get investment at a time when they needed investment. And now we're going to be scrabbling to try and create connections for offshore wind, because we've suddenly realized that the resources that are around the islands are what we actually need to decarbonize. If we'd listened 15, 20 years ago, it would be that much easier. So what we then need to do is get the good sites and market access, because it's not just the physical connections, it's the fiscal arrangements that create barriers as well. So if we did get the grid, we then have to wrestle with tenuos, the charge that's levied for putting electrons into the grid. And that gives eye-watering amounts of money to the system operators. If we're looking at, say, a 200 megawatt development in Orkney, at the moment the best estimate is it would cost £600 million through the life of that 200 megawatt scheme to use the system. £600 million just to use a cable. So that's a really big decision to make. Do we actually spend the 600 million using the cable, or do we do something more productive with the energy that we're going to use? And I'll show you some answers to that. And then underpinning all that is that we need the development plan and the finance. So we've coupled those together, because it's not just about getting money. You're only going to get money if you have a good project and a good plan. So we need to couple those two things together. So those are the 5 building blocks that we think we need for success. And 2 themes that I wanted to also share were, again, really born out of practical experience, was that we need to deal effectively with both place and time. And what this means is that there's no one-fits-all solution. You can't go and take a black box and put it into 1,000 different places, because each of those places has different requirements. And so we need to tune our offering to the particular conditions in a particular place. And then another factor is time. And so often I hear people, and I'm sure you've heard people say, 10 years ago we did this, 5 years ago we did that, 20 years ago that was the solution. And that's a true fact. But it virtually has no bearing on what we're about to do in the future, because for me, the future is totally different from what we had in the past. Everything that we're hearing is that the status quo is not good enough. What we have at the moment isn't delivering what we need. So if we look back and see how we've done things and say, well, maybe that's the model for the future, we're probably going to get to the wrong solution, or it's going to take us a lot more time to do it. So we need to think out of the box. We need to be progressive. We certainly need to learn from what we've done in the past, but we can't replicate it. We need to create a new, right future. And part of that is that it's really difficult to produce and predict, and probably it's wrong to predict a future. So what we need to do is have a set of credible scenarios, possible pathways that we could be following, and then we react to circumstances as we go along those pathways, and we come to key decision points and go down whichever pathway makes most sense. So the message out of that is that we can learn lessons from the past, but we need to plan and deliver something that's going to be better and appropriate for the future. Now that sense of past and future is something that Orkney has really embraced. And I'm not a born Orcadian. I've been up there 30 years, so this isn't my born heritage, but it's certainly a heritage that I've embraced having come to Orkney and lived there. And what we've developed is what we think is the Orkney way, and it's articulated there. It's about working together, collectively, creating the future. So not waiting for somebody else to tell us what the future is. It's actually going out there and making it happen, but in doing so, make sure we learn from the past. And what I'd like to do is just talk a little bit about how these islands have been able to make incredible strides in terms of sustainable energy over the last 20 years, and therefore how that might be a model nationally and perhaps internationally. Well, it's not perhaps, because it's happening. We are used as a model nationally and internationally. So it might be interesting to share that experience. So the first thing is that Orkney is not just about energy. It's many things to many people. It's got some great archaeology, which shows that there was innovation happening there 5,000 years ago. So it's a real innovation cluster, probably the world's first innovation cluster in the Neolithic, and it's lasted until now. Ptolemy, one of Rome's mapping specialists, had Orkney on the map in the 2nd century. So we've been significant for quite a long time. And what we've done now is really pull together this incredible community, incredible biodiversity, incredible archaeology and landscape with progressive, world-beating energy developments and technology developments. And like everywhere else, we're facing an incredible and unprecedented change. And we're just in the middle of it at the moment. And I'm not going to go through all of those things, but you can see things there that you and your own communities are having to deal with. There are some special ones that are particularly key to Orkney, but across natural change within our community, across political change, across climate change, across industrial change, all of these things are things that we're having to react to as a community. And because we want to be involved in that change, we have to organize ourselves to be able to manage and influence that change. And so what we've done is over the years, we've created a structure within our community. And this wasn't something we set out to do, but it's something that over the years has come together and gelled as a mechanism for working together. And what it means is that throughout our community, we have the capacity to look at vision, strategy, organization, involvement and engagement of people, action, and then getting support. And that, if you like, starts with a few at the vision level, but engages the many, which in our case is 22,000 people at the support level. That's the level of population in Orkney, 22,000 people. But it doesn't mean that somebody in the population can have a vision. You know, it's a very open society, so there's no blockage on anybody contributing in any of those areas. But what we found is that it's really important to recognize and have those levels of activity in your community if you're going to affect change. And the level of change that you can be influencing with that is significant. So in terms of the changes that we're looking at with carbon transition, there's a long list, not surprisingly, because we're going to take carbon out of our economy. And we have something in Orkney called the Islands Deal, which we share with Shetland and the Western Isles. And under that Islands Deal, we've said that we're going to decarbonise our communities by 2030. Now, for us, the net zero target is a bit of a kind of false dawn, because we could produce so much energy so quickly that actually net zero is almost meaningless. So we're looking for decarbonisation by 2030. So that's our houses, our boats, our planes, our vehicles, our heating systems. It's a really big ambition. But the reason that we've said that we want to get there is that we want to be a lighthouse community. We want to be up the front, kind of innovating and showing what's possible so that we can then help other communities follow. So the kind of things we're looking at are energy generation, infrastructure to support that. We're looking at energy transition in our buildings and in our transport infrastructure. But we're also looking at some of these enabling things, such as data management, which is actually a huge challenge as we look forward to the kind of way we're going to use energy in the future. We're also looking to build the capacity with our community to help keep as much of this change management locally. So we need to build skills in the supply chain. We need to have new people coming through, getting trained appropriately. But at the same time, we're trying to outreach to all of us within the community to keep us well informed about what's going on. And to engage with that world of investment that we hear so much about, we need commercialization tools and capacity within our community to go out and be able to talk to people that are going to be making the investment or helping us invest in our own future. And underpinning all that is then the governance and policy mechanisms that happen at a local level. So there's active things happening in each of those areas at the present time. So are we making any headway? What have we done? Well, the first thing is that we've decarbonised our electricity, and we actually did that in 2013, first of all. So Orkney has had a surfeit of renewable electricity since 2013. It's not a huge amount. Our kind of average demand on electricity at the moment is between 25 and 30 megawatts, but we've been able to deliver that from our own generated sources, which is primarily onshore wind. And Orkney was home to the biggest wind turbine in the world through most of the 80s and 90s. It was a 3 megawatt wind turbine, 2 blades. You can see the second one along there, a concrete tower, pop riveted blades. It was an incredible machine. So that's one of the things that we've done. And we're incredibly proud of that, but we also realize there's a much bigger task to do. If we look at our whole energy stack in Orkney, electricity is only 15% of our energy demand. Now that's quite low compared to other places. It reflects our place, not every other place, going back to that theme. And the reason for that is because we're an archipelagic community, we have ferry boats, ferries to the mainland, which burn a lot of energy. So we spend a lot of our energy on shipping and on vessels. We also have air links to Aberdeen, Glasgow, Edinburgh, Inverness, and our homes consume huge amounts of energy for heating. So we unfortunately have one of, if not the highest level of fuel poverty in the country. Over 60% of our households spend that threshold, more than 10% of their affordable income on heating. And some people are living in quadruple fuel poverty, so they're spending 40% of their income on heating their homes. So that's a real problem for us. So incredibly proud of the fact that we've decarbonised electricity, but incredibly aware of the job that we've got to do. And we're the good guys. We're further ahead than every other community. So it's kind of, well, maybe not easier for us, but we're on that journey. So it's sobering, I think, to think of what we've got to go through. And we're only going to do that by learning and going together. So one of the things that Orkney embraced really early on was that we have very rough seas, we've got very swift tides, strong winds, and so we saw an opportunity to be a test bed for the emerging marine energy sector. And you just heard today how many connections there are between the technologies in Orkney. It doesn't mean everybody's come to Orkney, but everybody's probably had a hand of Orkney somewhere in what they've been doing. And that's given us the chance to develop a kind of energy innovation cluster of expertise. And that cluster has been formed over 20 years now. It probably involves around 40 businesses and organizations across academia, business, community and government. There's about 350 people employed in the blue energy sector in Orkney. So 22,000 people, 350 jobs in the blue energy sector. There's another 600 mariners who aren't involved in the energy side, but they're involved in the maritime industry, which could be really important. And a further 250 energy people. So we have an oil terminal on Flotta, which employs about 100 people, 150 people, and other people that are in energy, but not in renewables. So in that marine energy space, we've deployed about 50 different models of turbine technology, buoys in the waters. But interesting, there's been another 50 or so innovations that have been created through the supply chain in Orkney to support that business. So somebody comes with a bright idea, they don't have all the solutions and say, can you help me do this? Can you help me do that? And somebody says, oh yeah, here's one either I had earlier or I developed for somebody else. So we've got an innovation cycle going on there. And that's led to international interest. And we've got connections and collaborations going with over 50 countries at the present time. And a number of us have been involved just this week with the Indonesian delegation at COP. And they're coming up to Orkney in a few days because they just want to touch base with us and see how we've progressed. Because interestingly, Indonesia has been to Orkney about 8 times now to see what's going on, which is considerably more than some of our national governments have been. But anyhow, Indonesia likes to be at front of the game. So all of that's taken money, and it's taken Orkney's money. Orkney's invested around £300 million in that energy transition to date, and that is about just under a third of the £1 billion that's been spent in the last 20 years on energy transition. So I think that's a really interesting fact as well, is it's not everybody else doing the investment, it's about us. It's actually about all of us in here. It's not going to be anybody else that creates the money. We all create the money through what we buy and what we know, the taxes we pay, and that's what's going to pay for the transition. So if we want to influence it, we need to kind of put our hands up and say, we think you should be doing this more and some of that less. So one of the other things that we struggled with was our energy system. Like every other part of the UK, we live within the same system. In about 2002, 2003, the government made a decision, and Offshore made a decision to basically not include the islands in the grid settlement mechanism that was created at the time. And what that meant is that getting grid connections started to become really difficult. And as we asked more, it seemed to get more and more difficult. And then in the intervening time, we've tried a number of innovative approaches to decarbonising our ways of using electricity and energy, and they've been really blocked by the regulator and by the system operator. So what do you do if you don't have a supportive regulator and you don't have a supportive system operator? You have to go and do it yourself. So 3 years ago, a team within Orkney set up a project which got support from Innovate UK for the Reflex project. And Reflex is about delivering an energy system of the future. It's about digitally connecting generation with demand in a flexible way, building in flexibility and control so that we can better use and distribute our energy. At the moment, we've got generators, wind generators, that curtailed as much as 50%. We've got very high levels of fuel poverty. We need to find solutions that start to create a better balance within that. We've asked the system, can you help change? No. Okay, we'll do it ourselves. So what we do at a more practical level is think about how we can improve our housing stock, how we can put assets into houses. And one of the challenges that comes with that, and you'll see this, I was actually watching the news last night and somebody said, but how are we all going to be able to buy cars and buy heat pumps and things like that? And it's a question you can ask. But do we not all buy cars and buy heating systems and fridges and cookers? Now, that's not trying to be flippant, but we need to frame the question in the right way. We all in our homes buy energy-related equipment all the time. Some of us have nice stuff because we can afford it. Some of us don't because we can't afford it. So within Reflex, what we've done is recognize that we can't just supply and sell people new equipment. We need to be able to lease or hire people stuff so they can afford it. We need to work with second-hand as well as new equipment. So you don't have to go and buy the latest Tesla, although that's become the fastest selling car in the UK. You can go and get an 8-year-old Leaf, and that will cost you £2,000 or £3,000 at the auction. So that's what Reflex does. It helps people. If they want a Tesla, we can supply a Tesla. If they want a Leaf, they can get a Leaf, and a second-hand Leaf at that. So one of the other things that we needed to do was to make it accessible to people. So we've got test drive vehicles which people can come along, hop into, and decide whether or not they like EV driving. And our conversion rate is 50%. We've had orders for EVs from half the people that have sat in these cars. So that's a really good conversion rate. So it shows that if you engage with people in the right way, you can have a consequence associated with that. So there's a website, and if you're interested in looking at what Reflex Orkney is doing, very welcome to do it. At the moment, Orkney is the only place where you can access the services, unfortunately, but we are hoping to roll that out to other areas. And we've got 700 members of Reflex. You become a member for free, and then we can communicate with you, gets through all the GDPR issues, etc. And then we can start transacting, and we've got 120 new EVs leased. We already had 300 EVs in the community before that, so it's added significantly to that. We've got 100 household battery systems ordered. We've got smart heating and building management systems coming through, and hydrogen and battery infrastructure planned as well. And I mentioned that at the moment Reflex is focused on Orkney because that's the pilot project that we're running. But all of these dots in the UK and around the world are places where we've had conversations or visits about Reflex with other people. So you can see there's a huge amount of interest in replicating Reflex in other areas, and that's one of our opportunities, is as we prove the business model, to take it to other places. So hopefully you may have the opportunity to rent, lease, buy a car, a battery, or something through a Reflex community-based energy company in a region near you. And if you're really interested in setting that up and getting involved, come and speak to us afterwards. We'd love to hear from you. So one of the other challenges that we've started looking at, and this is connected with our failing grid, is that we couldn't export all the energy that we were producing. As I said, our turbines were curtailed. And so not just talking about hydrogen, EMEC and Community Energy Scotland set about creating hydrogen infrastructure. They went and got grants to help with that, and the map on the right-hand side there shows what we've got. So we've got tidal machines and wind machines feeding into a hydrolyzer to create hydrogen, which is then shipped to the mainland, and it's used there for heating, for transport of vehicles, and also to support what they call cold ironing for ships. So it's providing the power to ships at night. And alongside that, we've then got spin-off projects, one called Hydyne, which that ferry on the top there is running with a hybrid fuel where there's hydrogen being spiked into the diesel that it's running on. You can see there we've got an aircraft being serviced, and I'll come on to that, but we've got new planes that are being trialled in Orkney and run on green hydrogen that's been generated in Orkney. And that bottom picture is EMEC's hydrogen production facility on Flotta. So we've had a fantastic start. This infrastructure has been in place for about 5 years. A lot of learnings from it. Some things have not gone well. You have to adapt to that and come back ready to do more. So one of the things that we've learned is through the shipping side, we think there's an opportunity for the fleet of around 150 vessels that we have in Orkney across our fishing fleet, our workboat fleet, and the ferry fleet, to use them as test boats for new forms of propulsion. And if we're going to decarbonize our community by 2030, all of these boats need to either be changed out or replaced by that time. So we'll call it the Lego program. Basically, you get a Lego brick, which is the propulsion system, and you drop that into a space, which probably Chris's team has designed, so it's universally applicable to every kind of propulsion system, and basically allows us to trial different propulsion systems within different hull configurations. And we also have the Pentalina ferry, which at the moment is not being used, and we think that is an excellent test platform for these different systems as they get proven. So that's one thing that we're looking at, and we've got a project called HyMet, which again funded through UKRI, so £7 million to be spent in 7 months looking at decarbonising shipping. I mentioned the aircraft, and Highlands and Islands airports have established Kirkwall as the first green aircraft base, I think, in the world. So there's a new hangar that's being built for servicing the planes there. And each of those planes, you can see in the pictures, are destined for Orkney or have flown in Orkney already. And the intent is over the next 18 months, probably to start passenger flights with either an electric or hydrogen plane. So what's fantastic for us as islanders is that that means that we'll have a means of continuing to move around, because obviously when everybody says we've got to stop flying, for us it's a bit of a necessity. You know, we don't have the luxury of a train or another means of traveling. So this is a really good solution, and hopefully as it gets proven at this level, then it can be scaled up to larger systems. And the other thing that we've started looking at is port and harbour infrastructure. This has been something that Orkney has recognised on many occasions, and we've had 3 iterations of investment. This is the 4th iteration, which was planned over the last few years, called the Harbour Master Plan. And you can see here a facility that was designed to be a hybrid between oil and gas and offshore wind. But one of the questions that began to emerge as ScotWind came onto the books was this going to be enough? Because Orkney, as I said, we want to create the future. We don't want to wait for somebody else to create it. So we're trying to think ahead and think, you know, is what we're planning appropriate for what we need in the future? I'm just going to pause there. Any questions that are emerging out of that so far? Any points?
Do you see a time that you cut the cord with the UK and set your own energy prices? Is that where you're going with it?
So Chris was saying, could we see a time where we cut the cord with the UK and set our own energy prices? So interesting. So Orcadians are some of the most loyal people. Like, we voted against, well, it depends. We voted against independence very strongly at the independence referendum. We voted very strongly against leaving the EU. But, and there is a but, that if things didn't go the way the islands wanted, we have a very strong affinity and admire Faroes, which are just 200 miles away, population of 55,000, and they're like 99.9% independent of Denmark now. So I couldn't say yes, but it's definitely something that's talked about regularly.
It's more on the electrical side than the political side.
Well, yeah. They are connected, but certainly from an electrical point of view, well, you heard it today. You know, if we wait for the system to deliver us something, we're not going to get what we want. So Shetland, Orkney, and the Western Isles are all looking at independent energy systems that might be integrated and will help deliver decarbonised energy for the rest of the UK, which I'm going to come on to. So the question here is then, how can what we've achieved in Orkney actually help the UK as we scale up? So what is the UK challenge? So this is some information from the Energy Trends report. And what that shows is the difference between 2019 and 2050. So there's a reduction in gross energy, but it transforms from a mixture dominated by hydrocarbons to something that's dominated by hydrogen and electricity. And based on that figure, we come up with a number of about 100 to 150 gigawatts of a gap, if you like, that needs to be provided. So 150 gigawatts, it's a lot of wind, it's a lot of energy. So these maps show on the left-hand side ScotWind 1, so that's what's in the leasing round at the moment. And you can see the circle puts the dot firmly in Orkney and shows a radius about 150 miles from that. So those waters that are encapsulated by that are not only productive for ScotWind 1, some of you may be aware that there's the ITOG round that's being heralded, and we think there is going to be ScotWind 2, and there's probably going to be ScotWind Plus. So we can foresee around 100 to 150 gigawatts of energy within that circle. Now that is an incredible amount of energy, but what's really interesting is that Sullom Voe, the oil terminal in Shetland, and Flotter in Orkney have handled 60% of UK's oil production for the last 40 years. And that equates to about 30% of our total energy demand. So for the last 40 years, the islands have been handling 30% of UK's total energy demand. So this idea of the islands being a hub of UK energy is exactly where we've been for the last 40 years. It's just it's never recognized or acknowledged. So what we're thinking is we can shift from providing 30% of oil to maybe 50% of renewables, because that amount of capacity probably equates to about 50% of what's going to be needed. And the map on the side there is some work that was done at Oxford University looking at the LCOE of offshore wind, and it shows that the most cost-effective areas for producing offshore wind are around the islands. So I think it was Cameron, wasn't it, who talked about the 10 weeks, a gigawatt. So I've done some quick cross-checking on my maths to make sure we were aligned. So what we did here is looked at, if you're going to get 150 gigawatts of 15, 20 megawatt turbines, how many turbines a day or a week do you have to produce? And the number that we come up with is that in the UK, just to serve that market, we need to produce 2 to 3 wind turbines a day, which are then sailed out and installed at their position. So if you're going to produce that number of turbines, and that's every day for 20 years, by the way. So that's a big undertaking, because you need to be ready to go when the weather window comes. You need to have assembled the turbines, you need to have them stored, and you might need to be maintaining them. So the numbers we came up with were having about 6 to 12 turbines in assembly, another 12 or 24 assembled turbines in storage, and another 12 to 24 turbine elements ready to go, because you want that supply chain to be ready. So we need the space for that. That's a big area. So how big is the area? So we laid it all out, roughly. Good PowerPoint science here. But what it means is that you need a laydown area of around 120 hectares just to store the equipment that's coming through the supply chain. And about 18 months ago, the UK government made a call on, they put some money to improve the manufacturing capacity of the UK for offshore wind. And we actually put an application in for this facility, which isn't strictly manufacturing, but it's an assembly facility. And this is what the islands are proposing for Scapa Flow. So that question that we had about our relatively small shoreline port was that enough? We don't believe it is enough, but we think that this might be. So this is a floating port which has 200 hectares of surface area based on pontoons that are 200 meters long and 100 meters wide. It's got 14 kilometers of quayside space, which is what we think we need for that intensity of activity. And because it's floating, all of the outside areas are usable. They're all in 25 meters water depth. There's no draft issues. So we think that that can be delivered for around 7.5 to 10 million pounds per hectare. And if you do the quick maths, you'll come up with something around 2 billion pounds for that facility. But because it's modular, you don't have to do it at once. You can do it in a staged way as the sector builds up. And it would produce by far the world's biggest offshore wind hub. And because it's right in the center of that epicenter of activity, and Scapa Flow is the only place where that can be done, and I'll show you why, we think this is something that needs to be seriously thought about. The important thing here is we're not competing with Tyneside, Teesside, with Invergordon or any of these other places, because we're not talking about manufacturing, we're just looking at bringing components and assembling them together. And at the scale that we need to achieve decarbonisation, that cannot physically be done in any of the other locations, we believe. And this is the reason why Scapa Flow is so important. So Scapa Flow is the largest natural harbour in the Northern Hemisphere. It's so big that Edinburgh City would fit in Scapa Flow. So it's huge. And that facility I showed you there is the orange bit in there. And basically we've got space for space for the mega hub in Scapa Flow without displacing any of the other activities that are already going on there. Now, some of those activities are actually ship-to-ship transfer of oil. So it's probably likely that they're not going to be happening in 20 years' time. But at the moment, we're not having to displace that to put the mega hub in place. And what's interesting, that some of you may be familiar with, between Denmark and Germany, there's a tunnel that's being built at the moment in Rotbyhaven. And the way they're doing it is to create 200-meter long, 70-meter wide sections which get dropped onto the seabed. They stick them together with glue, super glue, and then pump the water out, and you've got a tunnel on the seabed. But what's really interesting there is we've got a modern day kind of cost comparison of building 200-meter, 70-meter wide pontoons that will give us a really good indication of what it could take to deliver that facility in Scapa Flow. So I mentioned that it can be modular, and this is how we see it building up. So as of today, if somebody wanted to come and assemble a 15 megawatt or even a 20 megawatt wind turbine in Scapa Flow, it's a commercial port. You could pick up the phone and say, I'd like to do this, and they would issue an anchorage, and you could get on with that work and do it as part of the existing harbour regulations. So there's no impediment to assembling wind turbines in Scapa Flow at the moment. The challenge comes as you scale that up. So what we need to do is go through a planning process for when we start stitching these things together and delivering them as a whole. So you can see there that on years 1 to 2, we can do that now. Years 3 to 4, it's going to take a bit of time and investment, obviously, and then you get to the full Monty in perhaps years 4 to 6. But that can be market driven. We can match that to the needs of the sector. And at the moment, our working assumption is that we could end up delivering the service, which would be the assembly and delivery, for around £1 million per turbine. Now that's not a hard and fast number, but everybody says, how much is it going to cost? You've got to start somewhere. So that needs to be worked on, but that's where we're at the moment. So just to reinforce the point that there is really nowhere else where this can happen is the other major ports around the UK and their footprint in comparison to Scapa Flow. This is on a like-for-like basis. This is the same scale. So I couldn't put it on the same picture and show the size of these other ports with Scapa Flow, because Scapa Flow is so big that the other ports just become, unworkable. But that's why Scapa and this idea is so different and additive to what's being done elsewhere. So as well as the port facilities, it's also the boats, because to take all of those turbines out to sea to the different places, this isn't a one project facility, this is a sector facility. So there might be turbines going out to the west, turbines going out to the east, turbines going north, turbines going south. So there would probably be a fleet of around 100 vessels. And talking to Bays, they and Department of Transport, they really expect offshore wind to be running decarbonised vessels for putting ScotWind and ScotWind Plus out at sea. So there's another challenge for us to face, is it's not just generating the power, but it's facilitating that with decarbonised tools. So one of those fuels and tools might be hydrogen. And I mentioned, I think, that we have the Flotter Oil Terminal on Orkney. And Repsol Sinopec, who run that at the moment, realised that their lifespan is diminishing as oil phase out comes along. And so they just announced last week, this is something that's been going on for a long time, but they finally announced that they've been looking at that conversion of Flotter to a hydrogen generation facility with a consortium that are bidding for ScotWind, one of the ScotWind leases. So that's a real marker in the ground. Again, it shows a bit of joined up thinking. Shetland have a very similar project, the Orion project, which in parallel with that, Aker, some of you may be aware, just announced, I think 2 days ago, that they're going for a 10 gigawatt hydrogen production play off west of Shetland. So this is separate from ScotWind. This is just 10 gigawatts for good measure, just because we can do it. Yeah, 10 gigawatts, it's just incredible. So what it shows, that there's a reality here. This isn't just pie in the sky. I mean, I sit there and I pinch myself sometimes thinking, is this really real? Can we really be talking about that level of investment? But it's happening. People are making moves. People are changing things. Things are happening. And one of the other things that's happening is that the Arctic ice is melting. And so before all of this kicked off about offshore wind, Orkney have been thinking about Scapa Flow as a strategic base for future trade across the Arctic. As the Arctic ice melts, ships that currently go through Suez and around Cape A Good Hope from Singapore to Europe will probably come across the Arctic. And places like Scapa Flow are the obvious hub for that traffic. So as well as having the facility for assembling wind turbines, we're very likely to have a container handling facility for transshipment in Scapa Flow as well. And that will link into the supply of materials. It might mean, for example, that components can be shipped in very cheaply from the Far East. It might also mean that there's an additional fuel demand. And so I mentioned about data, and I think that's really worthwhile thinking about as well, because a lot of the comms and data requirements for all of this are going to be quite intense. And some of you may be aware that Microsoft tested a subsea data center in Orkney a couple of years ago. That test went very well. And the fact that Orkney and other places, as you go further north, are cool or cold is a great asset, because it means that you don't have to cool down the servers. The natural environment does that for you. So we think that this is another area which could be a big line of business for the islands going forward in the future. So what does that mean in terms of investment? What we've done is we've looked at each of the segments that we need to decarbonize our local communities. And this is now moved under the islands deal. We've looked at Orkney, Shetland, and the Western Isles together. So this is saying 3 islands, basically of 25,000 people, what would they need to invest to decarbonize their economies? And we need to think about our houses, we need to think our workboats, our vehicles, the existing infrastructure, and each of those boxes represents a part of our economy. If you total all that together, it comes to about £9 billion. Now that £9 billion isn't all new money. Some of that would have been, we'd have bought new cars, we'd have bought some new boats, we'd have bought new houses, etc. But there might have only been, say, 5 or 6 billion. So it's the difference between that that's new. So what we're looking to do is, in addition to that £9 billion, is ScotWind will probably lead to an investment of around £20 billion over, say, 10 gigawatts, something like that. Adam could give us some much more accurate numbers, but anyhow, let's go with that for now. And so that means a total, we've calculated 10 billion, which leads to 20 that gives us 30 in total. And then if we look at ScotWind Plus, that could lead to another £130 billion investment in that circle. So we started to say, are we ready? You know, what can we do? How do we contribute? Who's going to be doing what in that matrix? Because this is an unprecedented opportunity. It could all go very corporate. It could ignore the islands. It could ignore SME communities in Scotland. Or we can be a part of it. But we're only going to be a part of it if we put our hands up and say, we want to get involved here. We want to help give you the roadmap, give you the plans, give you the ideas about how this could work best. And this goes back to the conversation earlier on, is that, you know, does government in Westminster or Holyrood or Brussels actually know how to deliver £130 billion of investment? Do they know that better than the people that have done it for the oil and gas sector and for the renewables to date and the fishermen that have sailed those seas for centuries? You know, my proposition is that we've got as much chance as anybody else at coming up with that future. And if we look at the mess we get with some of the other decision making, we've probably got a better chance of this. So let's have a go. Let's give ourselves a chance to be innovative. Because as we say, the status quo is not good enough. The status quo has got us where we've been before, and that's failing us. So we need to go somewhere different. So what we're doing in the islands is using some of the tools, some of the mapping tools, some of the insights, some of the experience that we've done to help create maps of where it's good to do different things. And this is an example of looking in an Orkney context at where's best for wave development, tidal development, cable development, and substations. So we have those tools available. We've got the combination of infrastructure, people, all of these other things to help make it work. And the key question is it worth it? And we believe it is, because we can deliver somewhere between 20 and 50% of the UK's total energy needs from that area. So it's a significant win. So I am going to pause there. I'm going to get a time check. Any questions about that little piece? Hopefully, I hope you found it inspiring. I certainly find it inspiring to speak about, and I never tire of it actually. But if anybody feels that is not real, it may be unreal, there may be some things there that are wrong, really happy to get feedback about that as well. Please.
Gareth, very, very insightful, and as you say, lots of kind of innovative thinking there in terms of how we deliver offshore wind. In terms of the idea around Scapa Flow and the floating harbour, I mean, what does the regulatory regime need to look like to deliver that? And what are your thoughts around who's going to own and operate the asset?
No, so Scapa Flow is an established port harbour area. So the area we're looking at is a designated harbour area already, which helps us. It's also in the throes of a legal discussion about whether it should have a new SPA designation thrown on it for protection of birds, which may be less helpful. But at the moment, the reason we've gone for the floating approach is that we believe it has a lot less environmental impact than a shore-based approach, because most of the land around Orkney and the shores of Orkney is pretty precious as well. So it's not without its challenges, but if you think of Scapa Flows already used for mooring tankers, for transfer of oil and gas between tankers, it's used for fish farming, it's used for recreational diving, it's used as a military anchorage. There's a lot of things that go on there already. For sure, this is an expansion and a development of it, but it's not unprecedented. And from what we've seen of how the community and the ecological side adapt to the use of Scapa Flow, it's not going to be trouble-free, but it's achievable. And so that's really where we're at the moment. And I mean, obviously, as many of you know, we've got the best expertise in Orkney to actually deliver that permitting pathway as well across the community and within the community. And so the second question was, there was the permitting, and then, oh yeah, and in terms of the owner-operator, so what we've established is a company called Scapa Flow Futures already, which is an SPV, and I envisage that SPV will be an enterprise that has community interests as well as local business interests and some of the founder technical support players, and that entity will then partner with investors, larger scale investors and specialist operators in each of the parts of the business. So rather than trying to find one partner, what we're envisaging at the moment is finding a specialist port operator, probably a turbine assembling team, an energy production team because the site needs energy, a pontoon delivery and maintenance team, and a vessel support team. So there would be probably 6 entities involved. And what we're also very keen to do is do it in a collaborative way. So we're trying not to make it a winner-takes-all situation. We don't like that. It's not how islands work. But we want the islands to be in charge this time. The Flotter Oil Terminal, which we've lived with, which has been incredibly successful, but we have no control over that. It gets shipped from asset holder to asset holder without any local content, and we don't want that to happen this time around. So we want the entity to be led from a community base, and the community will be involved until that facility stops operating. I've got maybe 15 minutes more, which takes this into a global context and particularly focusing on Indonesia. If you, it's like a vote. How many people want to go on? How many people want to stop now? If you'd like to stop now, put your hands up. And don't be embarrassed, I'm not embarrassed. If you've got another 15 minutes to go through Indonesia, yeah. Okay, thank you. It's a bit like an encore, isn't it, at a concert? Yeah. So applying this approach globally. I'm I mentioned in one of the earlier slides that Orkney is engaged with about 50 other countries around the world, and I think one of the ways I capture this is if you live in a place like Orkney and you get in a plane to go somewhere, it's really sad if you stop in the Central Belt or London. You want to go somewhere a lot more exciting. And so over the years, Orcadians, even actually before our generation was involved, have literally traveled the world. We're involved in whaling in the Davis Strait. There's a Stromness in South Georgia. There's South Orkney Islands in the Antarctic. So we've kind of got around the place. So the renewables team in Orkney, one of the reasons we're very, very committed to decarbonisation is that we've built up a hell of a carbon footprint over the last 20 years travelling the world. So we've got a personal responsibility there to do something about it. And what we found is that the island approach travels really well. We've got really good reception in many parts of the world, and that's been really helpful. So what we've often been asked is about marine energy, because that's the place where Orkney is most famous historically. All of the stuff we've done with wave and tide, how can we do that in other places? So one of the things that's really helped us is the burgeoning availability of digital data. And those in my team will know how much time I spend on Google Earth, ironically probably looking at Google Water, because it's incredible what you can find out about the world by the photographs that are just available to you on your laptop. So what we do is we search the world for clues about markets, about opportunities, about people and businesses, enterprises that may need energy, and look for sweet spots where the circumstances suggest that it may be something that we could develop. So you can see here some of the data sets that we use. And what's become really interesting, I think maybe 10, 15 years ago, we did concentrate on tide or wave or wind, and we looked at it in isolation. But what we do now is every time we go somewhere, we immediately look at all the resources to see what the mixture might be able to deliver. So instead of looking to how individual assets might be deployed, we look at coopetition. So we look at cooperation across those different technologies. And what we also have to be aware of is what are we competing with? So what we're competing with is the incumbent power generation systems. And I think this map is fascinating in a number of ways. First of all, the colors show the different types of dependency that exist in different parts of the world. So the black, not surprisingly, is the coal. So you can see where the coal replacement is. And I mean, fantastic results coming out of COP in terms of countries committing to coal replacement earlier than was otherwise thought. But we've got other areas where there's hydro, gas, nuclear, etc., that need to be thought about as the competition to a renewables solution. And I think within the work that we do in Aquaterra and in Orkney, hydro and nuclear are not necessarily in the basket of tools that we're looking to use. There's real problems with both of those, so we're probably looking for non-hydro and non-nuclear solutions. So there's a range of terrestrial energy markets, going back to this idea of place and the square kilometre. What's the nature of the energy market we're trying to solve or secure? And there's marine energy markets as well. And then we've got a range of technological solutions. So we need to think about how appropriate a particular technology might be in a particular area, both on the land and on the sea. And as technologies come, that choice gets wider, and unfortunately, as they disappear, the technology choice becomes smaller. But what we need to do is find the right technology for the right application in the right place. And there's not many times when I disagree with Andrew Scott, who spoke earlier, but he talked about convergence. And he and I have had this conversation for 20 years now. But I do wonder whether convergence will happen in the way that people talk about in the marine energy sphere, because my experience as a marine scientist is that each of the places where we're going to generate energy are so different and distinctive that I think there are opportunities for a wide range of technologies. So I don't think we are going to see convergence as a particularly strong trend, perhaps other than at the biggest end of the market. And one of the other things that we need to think about is energy storage. And it was really great that we had so much discussion about that early on. But the appropriateness of generation is going to be linked to the capacity for us to deliver storage and flexibility solutions with that. And if you think back to the Reflex project, what that's shown is that it's not necessarily providing flexibility at the generation end. It might be at the householder end or at the vehicle end. So there's a whole spectrum of places along the energy supply chain where we can provide that storage capacity. So a tool that we use then to help characterize places is this market definition scheme or market matrix, which looks at the value of a market compared to the size of the demand that's associated with that market. And what we then do is basically identify sectors on that scale. So how valuable is the sector per kilowatt hour? And you can go to sub-sectors and how much energy do those sectors need. And what you can start to see here is the sectors start to differentiate themselves. So if we're going for grid-connected electricity, that's the one that needs most capacity, but it's also the one that you can guarantee is going to be of least value. And that's the one where historically we've tried to play. But when we come down to instrumentation, security, and health, that's where little bits of energy can have an incredibly important role and be incredibly valuable. So if you've got a small wave machine or a small tidal machine or even a small wind turbine, you might be able to provide a solution there and get a big price per kilowatt hour for your energy. And I think health's a really interesting one because obviously since the COVID pandemic, one of the other, great vaccines were found. I think almost every vaccine needs to be refrigerated. Refrigeration isn't available in many places. So we're already seeing an uptick in, can you provide energy solutions that provide refrigerators to remote marine communities. So as well as the sector differentiation, we've also got technology differentiation on the same scheme. And what this is starting to show is that we think that different technologies have different sweet spots where they can play a role. And if we look at what's capacity at the moment and what can deliver low value energy, and this is in particular, actually this was drawn particularly for Indonesia, floating solar was the technology that we thought could deliver cheapest energy in that particular marketplace. But thinking about a place in this context of what are the values of the energy markets that exist and the scales that exist, we find really helpful going forward. And the same you can do with energy storage. So in terms of location-specific energy planning, what we then need to do is apply all this thinking and learning to an individual place. And a number of projects that we've looked at have tried to provide strategic plans. And the first question people usually come on a national basis and say, can you give us a plan for Chile? And as Adam knows, Chile is anything but uniform across its length. So the first point we come back to is that it's not possible to deliver a plan for a country. You need to have a number of plans which reflect the conditions in particular regions and sub-regions. Same true in Peru, where we were able to do similar work and look at this was looking at aquatic technology, so it wasn't just marine, it was looking at river-based technology as well. And it was really interesting to think of a place like the Amazon, for example, where when you look at the ground, all of the land is covered in trees, and then you've got a river. And you think, well, if you're going to put any energy system into that, you'd probably go for the river because that's least disruptive. But then if it's current, a lot of the river isn't fast flowing. But actually the river could perhaps be a place for floating solar. There's no wind there. So it's trying to use the resources that are available in the context of the place that you're in the right way. So that was a really good learning exercise in Peru. And somebody, I think it was on the tidal and wave panel, we were talking about modeling where marine energy can make a difference. And Orbital and Core Power are involved in a project called Evolve with a group of people in Orkney at the moment, which is looking to devise a West Europe model of how and where different types of technology can make a best contribution on a grid square by grid square basis. So what that will start to show us is if we're off Portugal, what are the technologies that make sense given the marketplaces that are there? If we're off the west of Ireland, again, what are the connections that are needed to deliver generation to the market? So just a few slides now, and this is kind of getting to the final story now about Indonesia. So Indonesia has been one of the countries that's been high on the list of people's attention. It's the 5th largest emitter of carbon dioxide in the world. And the numbers are there. So its total energy production, the equivalent of 5,000 terawatt hours. But most of that, 61% of it is exported. So interestingly, Indonesia's energy market is mainly an export market. So if we go in there saying, please decarbonize your energy, we have to think not only about how we're going to help Indonesia decarbonize its domestic energy market, but can we help it decarbonize its exports as well? Because its balance of payments would be shot to hell if we didn't do that. So we're looking for an established renewables equivalent of about 2.4 to 4 terawatts of total energy production needs to be delivered. And again, like most other parts of the world, it's not an even distribution. So Java, which is that brightly dotted island in the middle, is the most populous. And so that's where most of the energy demand is. As you move across to the far east of Indonesia, demand is much less. But of course, the way the world works, that doesn't necessarily reflect the resources. So this is a map that shows wind speeds expressed as capacity factors across Indonesia. And what you can see is that there's not many areas where there are winds. But interestingly, there are patches which are close to demand centers. So there's 5 areas where there's nearby cities or industrial complexes which could use offshore wind. And then there's that big area of greeny yellow stuff underneath Papua New Guinea, West Papua. But that's not near anywhere. But it's absolutely huge. It's an area of water that's about less than 50 meters water depth. And basically, if you look at the area, it's got enough for a terawatt of offshore wind in that area. So that's not going to be to support a domestic market, but it might be able to do something else. So if we look at Indonesia at a conceptual level, it's got different hotspots for energy across the islands. Solar's in one place, wind's in another, tide spread in different areas. There's about 260 different tidal streams. But of those, there's only perhaps 10 or 12 that actually are near markets that could use that energy. So what we've done is looked at all of the different energy resources and what might be deliverable. And this was done in comparison with Indonesian work, what Indonesia had done is it looked at its onshore resources to date, and they had 180 gigawatts of identified capacity for onshore renewables. When we looked at the blue energy resources, it came up with over a terawatt of capacity, so it dwarfed where they were at with their terrestrial renewables. But the confidence that Indonesia got from seeing that is basically part of their commitment to coal, because they couldn't see enough capacity here to decarbonize their coal sector. When they started looking at their blue energy resources, they thought they could do that. And what's really interesting about Indonesian coal is it's produced in 2 main areas. It's a big area, but Kalimantan, which is the old Borneo, and then parts of Sumatra. But a lot of it is delivered by barge. So each of the power stations that exist, coal power stations in Indonesia, already has a port infrastructure which currently accepts barges from Kalimantan or Sumatra. So it's ideal for us from a marine energy point of view, where you've got a power station with port infrastructure, and different power stations have different resources that are near them, but there's a lot of floating solar opportunities there. So going back to the question about grid, which we were looking at from a North Sea perspective, Indonesia has the same challenges. You know, how do we connect up all the islands? Again, they've been planning onshore grids and going through land there. We've been putting some suggestions in for maybe learning from our challenges about grid acceptability and going for subsea grid connections. And there's different energy resources that can be linked in along that chain. And one of the interesting opportunities, going back to this export link, is that these areas of shallow water along the Malacca Straits are potentially ideal areas for floating solar of considerable scale. that could then be exporting across 20, 30 kilometers to the Malay Peninsula, which has a lot of people but not a lot of space for energy generation. So this is something that's really excited the Indonesians because they can see that replacing some of their coal and oil exports going forward. And there's talk already of electrical cables being run from Australia all the way to Singapore through Indonesia as well. So the model that we're looking at for Indonesia at the moment has a mixture of energy sinks, which is about Londonshire, if you like, in the middle. You know, Java becomes London, everything feeds into London. And then you probably come up to Sumatra, which might be more akin to Orkney, Shetland, and the Western Isles, where we're feeding energy south, but also exporting energy, maybe in a different energy vector as well. But what you can see here is different solutions in different places. And this is just but one example of how that happens. So, some final thoughts. I think we talk a lot about technology, we talk a lot about finance, we talk a lot about inanimate things, but the biggest thing to my mind that has to change is our minds. We need to think differently about how we see energy, we need to think differently about how we do business, about how we organize things, because most of the challenges, and we again heard it today, you know, the problem is the regulator. It's not a technology problem. We need Ofgem to unleash the shackles of the grid system if we're going to find the right solution. They react to political guidance. It's just simply a conversation, and it's sorted. And it's taken us 20 years and we still haven't got it. So it's not a technical problem. It's not an investment problem. It's just a willingness and mind problem. So in terms of future actions that may help, I think definitely understanding. One of the things that we get really frustrated in the islands with is the idea of average. If somebody says the average utilization of energy is this, or the average per household cost of energy is that, there's nowhere called average. None of us are average. We're all individuals. And what ends up happening is policy gets guided by that because myopically people think that the average is the only reality that exists. There's a huge spectrum on almost every average. So we need to really understand what that diversity of options are. We should predict and manage, and national planning, again, one of the other panelists who spoke, I think from Latvia, saying, you know, not a great fan of planning, but planning used in the right way can be incredibly important and useful to us. We need to be aware of the technology options that are available and shape them to the world that we're in. We don't shape the world to the technology, we shape the technology to the world. Investing not only in the technology, but in the supply chain. I think one of the other conversations, how do we ready ourselves for what's about to come? We need to build businesses and we need to back small businesses. Chris, this goes to your point. If we don't back SMEs, the only pathway for an SME is to sell itself on to somebody else. So we end up with one mega company that owns everything. Is that really what we want, you know, in our society? We have to support businesses that want to stay independent but want to grow and do things. We need to create state and local social capacity and regulatory capacity. We did an evidence session for the Parliamentary Committee of Energy Parliamentary Committee, and they said, what's the greatest training need in, you know, to kind of get renewable energy and carbon transition? And the answer we gave them was you needed to retrain the regulators and the governance system. They were looking at, you know, welders, fitters. That's not what we need. We need people who are giving us guidance and policy to be retrained, to understand the challenge that's about where we are. That means raising public awareness, setting the targets. I think we've got some good movement there, and then monitoring performance on that journey. So in terms of going back to the original question, can blue energy make a contribution? As somebody has again said, we have enough onshore renewables, but they're not in the right place and always available to develop. So blue energy can provide additional capacity, particularly important to balance the ups and downs, because our ups and downs are going to be different to onshore energy. And there's a variety of energy services and commodities that blue energy can provide. Some of those are not really the focus of what we're doing at the moment, but we need to keep our eye on that. Water, in particular, the next war is going to be about water, all that messaging. We need to think about water as an energy commodity. So we need blue energy to optimize its offer to the needs of those markets. And on that basis, I think that blue energy can sit at the heart of the blue economy as well as sustaining the wider energy strategy across the world. So thank you. Thanks, Adam.
Gareth, thank you so much. That was a fantastic way to round off 2 days of really, really interesting conversations. I think when Chris and Cameron and I met in August, gosh, was it just August? And we conceived of these 2 days. We said what we really want is interesting chat. Because all the boring stuff will be happening over there. We want the interesting chat here. I'm very conscious you've been very, very patient. You've been a very loyal audience. The police have returned to supervise our activities. So I'm not going to take long, but I do have some particular thank yous in particular to make. But before I do, I can't let Ptolemy the mapmaker pass without comment. During lockdown, I read a biography of Sir Robert Murray, a lesser known but incredible polymath, Scottish. Did many, many things in his life, one of which was to get on the wrong side of Oliver Cromwell. And for that, he was sent into internal exile and was sent off to Bernera, where he spent a winter, actually 2 winters, I suspect, studying the tidal race. And when Charles II was restored, Robert Murray was one of the founders of the Royal Society, and one of the first papers given to the Royal Society with him in it, actually by him, somebody else in the chair, was on Scotland's tidal resources. So there we are. That's my challenge to you. Next time you're in London, go to the Royal Society archives and look up the paper. It may not be as old as Ptolemy's map of Orkney, but at least somebody was thinking about tidal energy back in the 17th century. I have a number of thank yous that, if you bear with me, but particularly Chris, to Eleanor, and all of your team here. Thank you so much for your hospitality, allowing us into your fantastic marquee for 2 days. It's been the best of events, and it literally could not have happened without you. It's been remarkable. To the AV team behind who've combated STV, trying to nick their bandwidth and keep the microphones and the films running. Thank you all very, very much indeed. To Regis, the caterers who kept us fed and watered, and those of us who've been inside for dinner as well. That was just fantastic. It's Glasgow's latest pop-up restaurant thing. It's been really, really good. We have had the most amazing suite of speakers, from the First Minister of Scotland to Gareth. And I'll leave you to work out which order you place them. But it's been an amazing couple of days. I need to, because we have an audience of thousands watching us on cyberspace, so I do need to thank our event partners, without whom we would not have been able to hold this event. I need to thank our our parent company, Aker Horizons, for the donation of this fantastic LED screen, which has kept us warm, those of us on the panel here for 2 days, but has added immensely, particularly to all our friends at Aker, for being with us over the last couple of days, to GWEC, to Supernode, to the Catapult, to the Scottish Government, to the Marine Energy Council, to Aquaterra, and if there's anybody else I've missed, you are very, very, very much thanked, because it's been an amazing event. To all of my mainstream colleagues, to Ewan, to Una, to Neve, who has left. Without Neve, this event would just have been an empty marquee with me rushing around going, what's happening? Anyway, Neve's taken 2 days off, deservedly, because she has worked tirelessly to produce the show that I hope you have all enjoyed. I set you a task yesterday, which was to answer Tim Lord's question: if energy policy is no longer a lasagna, what Italian food is it? Well, we have the winning answer. It's come from table number 2 here. Energy policy is now a quattro formaggi pizza, because it combines consumers, supply, grid and an unknown fourth cheese, which looks interesting, but we'll get to it later. And I think that summarises the last 2 days in the best possible way. But to all of you, whether you're watching us in the internet, whether you're here with us in the Rotunda, thank you very much indeed until we all meet again, whether it's here or wherever it is. Actually, no, for me, the best thing about the last 2 days is being able to see everybody in person, which is great. So thank you all very much indeed. Safe home. I hope you get to whichever station or airport or back to your flat safely without bumping into Greta on the way. But if you do, say hi. Thank you very much indeed. Thank you.